On to example 5. So, first maybe we should rewrite some of these and to find the derivative. Okay, so we don't have any parentheses here. So we can assume that this 5x squared is completely together. Alright, so notice there's parentheses later, so we can assume it's the cosine of 5x squared. Alright, so the derivative of that, we're going to have to use the chain rule here. The derivative of cosine is sine, or negative sine, right? Because anything with a co has a negative derivative. So it's sine of that same exact function, but we can't forget to use the chain rule here and take the derivative of the inside, which would be 10x. That's 2 times 5x. Alright, and if you want to rewrite it in a different order, we could just put negative, whoops, let's clear that out, negative 10x times sine of 5x squared. Alright, so there's the first one. Now this one's different. Cosine of 5, that's being multiplied by x squared. So some of you might think we have to use the product rule right here, but we don't. Because cosine of 5, that is just a number. That is just a constant value. So we're just thinking of that as a single number. So here we can just use the power rule to find our derivative. Alright, so it's our exponent times our constant, 2 times cosine of 5. And I'm going to put that in parentheses just so I don't forget that that's cosine of 5, not cosine of 5x. Alright, and then subtract 1 from the power, we end up with x. Right, on to the next one here. Now this whole part is squared, so maybe it would be helpful to rewrite it first. Okay, instead of cosine 5x squared, we'll be talking about, the cosine of 25x squared. Alright, so let's take the derivative of this. F prime of x is derivative of cosine is negative sine. Alright, and remember we changed it to 25x squared. And now we just have to multiply by the derivative of the inside using the chain rule, which would be 50x. Alright, and again, if we wanted to, we could rewrite it as negative 50x, so that way we don't mix it up, okay, or try to squish that in the sine function. So negative 50x times sine of 25x squared. Alright, moving on. So this one, maybe it would help us, again, to rewrite it. Okay, rewrite if necessary. Most of these are necessary, okay. So instead of writing it using that condensed form, okay, it might be a little bit better to write it this way. Now it's clear to see that we can use the power rule and the chain rule here. Alright, so if we're going to take the derivative, derivative would be 2 times that inside part, subtract 1 from the power, so that's just a 1, okay, times, now we have to use the chain rule because we had a function on the inside. What's the derivative of cosine of 5x? Well, that would be negative sine of 5x. And we had an inside function there, so we also have to multiply it by the derivative of the inside of that, so that would be 5. So in this case, if we were going to rewrite it and simplify, we get negative 10 cosine 5x times sine of 5x. Oops, times sine of 5x. There we go. Okay, so I know we didn't talk too much about this in class, but as something that you might want to be aware of, especially for multiple choice questions, this there's a double angle identity. Alright, I'll write it here, might have to erase it. So if we have sine of 2 times something, so if we have sine of 2 times x, we can break that down into 2 sine of x times, 2 sine of x times cosine of x. Alright, so if this was a multiple choice problem and you had to find the derivative of this, it might be in this form. Okay, that's one way that, but it could also be written using this identity here. Um, instead of 2 times sine of 5x times cosine of 5x, or negative 10 times that, we could think about it as, oh, why can't I think? Alright, it could be negative 5 times cosine of, oh, sorry. Alright, sorry, my brain's a little bit out of whack here today. Instead of writing it, this way, okay, 2 times sine x cosine, or negative 10 times cosine 5x sine 5x, we could also rewrite it. You might also see it in this form, negative 5 times the sine of 10x. Alright, so if you use this identity here, so it's negative 5 times that, using this identity, instead of writing sine of 10x, we could break it down as 2 times sine of 5x times cosine of 5x, half of that angle. That's why this is called the double angle identity. And if you have any questions on that, alright, I could go over it in class. There's also a cosine double angle identity that we could go over. Alright, so let's move on back to our example here. Oops. Let me get to my pen width. If I make it too thick, you can't see anything. Alright, so let's rewrite this. Instead of writing square root, we could change it to the 1/2 power. Alright, so now we can, when we go to do the derivative, we could use the power rule here. So that would equal 1/2 times that inside function, cosine of 5x, and subtract 1 from the power. So we get negative 1/2. We have to use the chain rule with this one, so the derivative of cosine of 5x would be negative sine of 5x. And we'd also have to multiply it by the derivative of that, which is 5. Alright, so if we were going to combine this, of course we'd like to rewrite it maybe in some other ways, some more usable ways. 5 times 1/2, that gives us 5 halves. And don't forget that negative. You might as well pull it to the front. Come on. Alright, so on the top it looks like we're going to have sine of 5x. And in the denominator we have the 2 from the 1/2. And this is negative 1/2, so I could rewrite that as the square root of cosine of 5x. Alright. Okay, so let's keep going. And this one, rewrite cosine of 5x squared, so I'll write it that way, but it's also the cube root, so it's to the 2/3 power. So if we go ahead and take the derivative of this, it will be 2/3 times cosine of 5x to the negative 1/3. We're subtracting 1 from that power. Alright, now we have to multiply by the derivative of the inside there, which will be, again, as it's been all day, negative sine of 5x. And using the chain rule, we also have to remember to multiply by 5. So rewriting that, 2 times 5 times a negative, we get negative 10 in the numerator. And we also have this sine of 5x. In the denominator, we have the 3, and this is cosine 5x to the negative 1/3, which would be the cube root in the denominator there of cosine 5x. Alright, I just have one more problem I want to go over today. Let's look at example 6. Find the equation of the tangent line. It means derivative. Anytime we see tangent, we want to think derivative of this at x equals pi. Alright, so if we're looking for the equation of a line, we need two things. We need a slope and a point. We might as well start off finding our point. We only know the x value. So if we plug in pi, Alright, 2 times sine of pi. Well, sine of pi would be 0, so 2 times 0, which is just 0 there, okay, plus cosine of 2 times pi, which would be 1, so f of pi is 1. So we can write that, that's our point, pi, 1. Now we just have to worry about finding our slope of the tangent line. Alright, and so in order to do that, we have to take the derivative. Alright, so the derivative of 2 times sine of x would be simply 2 times cosine of x. Alright, and then cosine of 2x, the derivative of that is going to be negative sine of 2x. Using the chain rule, we have to continue. Don't forget to multiply by the derivative of the 2x, which is just 2. Alright, so I can, now I could simplify or rewrite this a little bit if I want. 2 cosine of x minus 2 sine of 2x. Alright, so we found the derivative, but we need to find the slope at pi. So now we need to plug in pi. So 2 times cosine of pi. Cosine of pi would be negative 1. So 2 times negative 1 minus 2 times sine of 2 pi. Sine of 2 pi would be 0. So we get negative 2. That would be our slope. So now we have a point, we have our slope, we can combine those together. Alright, y minus y1 equals m times x minus x1 pi. Alright, and the only other way, if you like this way better, you're more than welcome to write it like this, 1 minus 2 times x minus pi. And we could multiply this out, but you do not have to. You can leave it just like that. Okay, so one thing that I do want to mention, I believe that you are capable of completing example 7 at this point. Okay, it won't hurt you to try. I would love to see you try. It will probably take me an hour to write all this stuff out because my pen and my computer are so slow. Please try to do example 7. It will not take you that long. And 8 if you are an overachiever, like everybody should be in this class. Okay, see you guys.